Welcome back. We're doing product rule again of derivatives. Now we have just a different example. So notice that here we have three functions and we're going to have to apply the product rule more than once. So let's say that this is going to be function f. So function f right here will be x to the power of 9, 3 to the power of x. And then we will have to apply the product rule within this function to be able to come up with a derivative of this function. So now we have two functions within this one function, and I want to call a and b, and we will find the derivative of function a, which is 9x to the power of 8. Remember, we get the 9, put in the front, and you drop 1 from the exponent right there. Okay? And the derivative of 3 to the power of x will be natural log of 3, and then 3 to the power of x. So now we have to apply the product rule, which is f prime g plus fg prime. And that works for any other functions. If you want to call it u and v, you can do that, a and b, and so on. So we're here trying to find a derivative of the f function. I have to apply the product within these two functions right there. So f prime or a prime times b, so a prime times b plus a times b prime, a times b prime. Okay, now g function will be secant of x, and the derivative of secant is secant of x times tangent of x. Now I have f prime, g, and g prime. So h prime of x will be f prime, this whole thing right there. So this is f prime times g. G is secant of x. So I'm going to put all of this and multiply by secant of x plus f. This is function f times g prime. E, ran out of room. So secant of x, tangent of x. Okay, so now you have two ways to go about this. I would like to distribute this and then factor it out and then change it into terms of sine and cosine. If you can do it all at once, more power to you. But that's how I'm going to do it. And this is not the only way to do it. So I would definitely run out of room over here. I'm going to try to write smaller, but okay. So secant of x times this guy right here. I have 9 x 8 3x secant of x plus x to the 9th power 3 to the x power natural log of 3. Why did I do that? Well, I know I'm going to end up having to factor it out, so I'm going to try to have them at least kind of close together just to look better, but it's not wrong because it's the commutative property. You can just write them all in any order. So I distributed right there. So plus x to the 9th power, 3x, and then secant x tangent. All right, we're getting somewhere. Now, I will factor this out. They all have x, to the 8th power, and they all have 3 to the x power. Oh, and they all have secant. Looky there. Okay. So we will factor that out. So x to the 8th, 3 to the x. That sounds funny. Secant of x. Now this divided by this, I have 9. Plus this divided by this, I have x natural log of 3. Okay? And then this divided by this, I have x. These two simplify, and then I have tangent of x. Hey, it's getting better. Looky there. Okay, let's rewrite secant and let's rewrite tangent. So I know secant is the same thing as 1 over cosine. Nine plus, nothing's going to change there. And then I know tangent is sine over cosine. Okay, you can stop right here because this is fully factored and it is in terms of sine and cosine. Or if this really bothers you, we can keep going. But this is good already. But you know, what else are we doing? Let's make this the common denominator, having cosine of x as the denominator. So all of this will be multiplied by cosine of x. So 9 cosine of x. This times cosine of x. This doesn't change because it's already under the cosine of x denominator. Okay. Now, you know, I would multiply this and make this all under one denominator by multiplying cosine times cosine is cosine squared. And then the numerator is not going to change because it's fully factored out already. And there's nothing I can do to make it prettier. All right.